Okay, let's do it. Are these functions inverses of each other? So if I said f of x equals 3x minus 2 and g of x equals x plus 2 over 3, find if those are inverses of each other. All right, so you can do it one of two ways. You can make one an inverse and make the other inverse, okay? Put them in that way. So if we try to figure out the inverse of each one, switch x and y, and then solve for y. So we add 2 to the left, and then divide off the 3. So y equals x plus 2 over 3, which is what g of x is. But does that mean that the inverse of g of x is going to be 3x minus 2? So switch both of those and solve for y. All right, multiply by 3 and subtract the 2. The other way is you just put one function inside of the other and see if it equals x, but then you have to do the same thing with the other function, okay? So either way, just figure out the inverses. All right. How about negative x squared plus 3? Okay, so y equals negative x squared plus 3. And y equals the square root of 3 minus x. Okay, this time I'm going to do the other method. If they are inverses of each other, you can plug one function into the other one. Okay? So we're going to substitute this in into the x function, 3 minus negative x squared plus 3. Okay? In for x. Because the inverse would switch your x and y, right? So typically you would say that this is what y is, so we need to substitute it in for y, but that's not what you're doing. You're trying to show that it's an inverse. So in inverse, x and y switch. So we're substituting this value in for x of the other function, all right? So when we do that, simplify, 3 minus, or it would be 3 plus x squared minus 3. So that's the square root of x squared, which is x. Check. But you must also go the other direction and get x as well. So we have minus the square root of 3 minus x squared. So we're substituting that in for the x of the other function, plus 3. So we square the square root, and the square root's gone. And then we distribute the negative, negative 3 plus x plus 3. The 3's cancel, and you get x. So yes, those are inverses of each other, but you have to do both of them. So you either find the inverses yourselves and show that they are the other equation, or you substitute one into the other equation, and vice versa. And when you do that, if they do not both give you x's, they're not inverses. So that's two different ways of doing this. Okay? So you can pick and choose how you want to do it. But either way, you still have to do both. All right? All right, moving on. All right, now you find the inverse of this. Let's start with y equals 3x plus 5. All right, find the inverse, please. Okay, so switch x and y. And solve for y. Oops, minus 5. Divide off the 3. So the inverse, the right way of writing it, is that. X minus 5 over 3. How about f of x equals 3x plus 2 over 2x minus 5. So I'll do this with you here. So you gotta switch your x's and y's. All right, so I'm gonna do that here. And you notice, oops, that's 3. Y plus 2 and 3x minus 5. Y. So now you notice you have y's in the top and the bottom. Well, you can't have in the bottom, so we need to multiply both sides by the denominator to remove it. Okay, so now we are going to distribute the x through. So 3xy minus 5x is equal to the 3y plus 2. Did I do, hold on a second. Sorry, the bottom's a 2. All right, so 2y. Oop, no, 2 there and 3 here. Ugh. Okay, that looks better. Okay, now the thing is, we need to get the y's together. That's the next step. So the first step is switch x and y. If you have multiple places where you have your variable, obviously the first step is always to make sure you don't have your variable in your denominator. And you also, the next step really is part of this, you got to get all those same variables on the same side of the equal sign. So that's the second thing. So if you're taking notes, the process is that. Get your variable out of your denominator, if it's there. That's the second thing. The first thing is obviously switch x and y. And then get your variables on the same side. All right, so I'm going to move the y over here. So 2xy minus 3y, and move the 5x to the other side. Okay, so I'm solving for y, even though there's an x there. But now I can factor a y out, and I have 2x minus 3. So that's the whole point of getting your variables on the same side, the variable you want. Because then you could factor out that one variable, because we only want one y. Now we divide off the 2x minus 3. So our inverse is 5x plus 2 and 2x minus 3. All right, let's move on. All right, let's do a few solve equations. So do something simple to start with. 3 to the 2x plus 3 equals 3 to the x squared. All right, so what we do here is if you have one base on each side of the equal sign and they're the same, you set your exponents equal to each other. They have to be equal. Otherwise, they wouldn't be set equal to each other. So you say 2x plus 3 is equal to x squared. And you should notice you have a trinomial there. So 0 equals x squared minus 2x minus 3. Okay, so now we factor. So x minus 3, x plus 1. You should be that fast at your factoring. Practice, practice, practice. So x is either 3 or negative 1. I'm not even asking if they both work. You'd have to plug them back in to see if they work. 3 doesn't work. Or I mean, negative 1 doesn't work. Sorry. Does it? Extraneous. Negative 1 squared would be 3. No, that's right. Okay, they both work. All right. But I'm not asking you to tell me if they both work. I need to know that you can solve the problem first. All right. Let's do one differently. Let's do 25 to the x minus 3 equals 125 to the 4 minus x. So the first thing you need to do is get your bases to be the same. Okay? Well, 5 goes into both of those. Well, you could use 25, except 25 squared is not 125, so that's too much. It has to be a base that raises to the same base above it. That's how you do it. You got to manipulate all your numbers to make it work right. All right? And then what do you do with exponents raised to exponents? You multiply them. And since our bases are the same, I'm just going to go ahead and put this down as 2x minus 6. Distribute the 2 through it. And then distribute the 3 through the other one. And then it's algebra 1 from there. So go ahead and finish it, and then look up at the answer. let's do another type of problem. Let's graph. Let's do f of x equals 5, 1/2 to the x plus 3. You got 30 seconds. Okay, should have been done. Your parent function, y equals a to the x. When a is less than 1, it looks like this. Okay, so all you're doing is quickly manipulating that function. So the 5 stretches it vertically, and the 3 vertically moves it up. So your asymptote moves up 3 places. But the point, 0, 1, that's not necessarily going to be at 0, 4, because the 5 increases it. So to get your y-intercept, you got to plug in 0 for x. So if I plug 0 in for x, 1/2 to the 0 is 1. Right? 5 times 1 is 5, plus 3 is 8. So you're at the 0, 1 went up to 0, 8. So it is going to go like this. Doesn't flip or anything. There's no negative sign there, so that's all it did. And if you wanted to be more accurate, you could plot another point, but that's not the point. The point is that can you graph it quickly? You know what it's going to look like. You just plot a couple points just to make sure it's right. Okay? Let's do another one. Your turn. Graph this one. F of x equals negative 1/2 to the negative x plus 8. 30 seconds. Okay. So, first of all, again, it's 1/2 to the x, so our parent function is that. So what do the negatives do? The negative out in front is a vertical reflection. So that means it does that. But then you have a negative inside the function, so that's a horizontal reflection. So that therefore flips it this direction. So it's the, oh, you can barely see it on the screen there. So it's the green function there. And the 8 shifts it up 8 units. So your asymptote is at 8. And it's not stretching anything, so it's your main point is still 1 unit away from your asymptote. So if it was stretching it or shrinking it, you'd have to plug 0 in for x. If you plug 0 in for x, again, negative 0 is 0, 1/2 to the 0 is 1, but you got a negative out in front. So that's negative 1 plus 8 is 7, and that's where we put the point. And then you have to graph it at that point, which would look like that. Oh, I'm sorry. It's the green one. I went the wrong way. It's this way. All right. Let's go on to section 3 for the sake of time, and then we'll do some more in another class. All right. So you have to know this formula. Okay? You have to know it. I'm not giving it to you. So make sure you know it. So I'm just going to give you something like this. Your principal's 1,000, your rate's 5 1/4. I'm going to change the numbers on the quiz. And your years is 5. So you're only going to get this piece. And then I say compounded after t years there. Obviously, if t is anything at all, then it's not your PERT function, because PERT is continuous. Okay? So if you see t, you shouldn't be using PERT. That'll be the next example. All right, so now you just plug everything in. Plug and chug. But the biggest warning is the 5 1/4, which we talked about yesterday. That's 0.0525. And we're going to do this quarterly. I didn't put that in there. Okay? So quarterly means 4 times a year. So 4 times a year for 5 years. And then you just use your calculator and try to figure it out. I'm going to talk through the calculator process here. So obviously that's 20. That's the first thing you need to do. The second thing you need to do is what's in parentheses. You could do that first, but you got to do the division then. 0.0525 divided by 4. And I would write it out separately. All right, so add 1 to it on your calculator, and then raise that to 20 on your calculator. I'm hitting enter after every time I do this. So I have 1,000 times 1.29796. And that the 1,000 just moves your decimal 3 places to the right. Ugh. So $1,000 invested at 5.25%, compounded 4 times a year for 5 years, gives you almost $300 in interest. Not bad, but it could be better. All right, and one last thing for this class. Let's do this one here. X cubed 4e to the 4x plus 3x squared e to the 4x. All right. Okay, so when you have a problem like this, you have to look for the factors. It's wanting the zeros. So you have to look at this and say what is common between the two terms that are listed. If it's trinomial, you factor it.
What's weird?
Okay, so there's a multiplication and then a plus sign between them. So there's 2 terms up there. So what is common in the 2 terms? It's not a difference of squares, so can we factor anything out of those 2?
4x cubed.
Well, that only has an x squared in it.
I meant like the 4x above both.
You can take an x squared out of both of them.
E4x.
And e to the 4x out of both of them. And what do you have left?
4 plus 3x.
4x plus 3.
Why is it switched?
Hmm?
You tweaking good.
Okay, so now you need to understand, I mean, when we're getting ready to do logarithms, and I'm going to show you how to use those and the basic stuff behind them. And e is the natural log, but what we can do here is understand what the zero product formula is. And you say, well, I don't understand that. Zero product formula means anything, if it's all multiplication, which it is, you got x squared times e to the 4x times that group. If any of those 3 things is 0, then the whole thing is 0, right? That's what that says. If you're multiplying, if anything is 0, the whole thing is 0. So this right here, if x is 0, then the whole thing is 0, right? 0 squared is 0 times e to the 4x is still 0 times that quantity is still 0. So one of your options is if x is 0. And then you look at the next thing. What makes that go to 0? Negative 3/4. You set it equal to 0 and solve, don't you? Isn't that what you do when you factor a trinomial? You set your binomials equal to 0 and you solve them. So it's the same thing. So negative 3/4 is the other 0. Okay, that's not on the quiz, but it is on the test. So let's move on from there, okay? If I said solve the equation, let's do e to the x squared equals e to the 7x minus 12. You have 30 seconds to solve it. All right, time's up. So your whole goal, whenever you have exponents like this on both sides, you need to get your bases the same. And the bases are the same. Well, if your bases are the same, then the exponents must be equal. So x squared equals 7x minus 12. That's what you do. It's a trinomial, so let's move everything to one side. and solve. Your factoring skills should be good. Minus 3 minus 4. And there's your zero product formula. You have two things multiplied together. If one of them 0, they're both 0. So if x is 3, that makes the first one 0. If x is 4, it makes the second one 0. All right. Next one. So you have to know the formula. It's not going to be given to you. N times t, sorry. You have to know it. So this is not a continuous problem. We haven't done a PERT problem yet. We'll do that here in a second. We'll do it with the same thing. Let's do it the same way, depending on what it is I give you. So you have to know both those. So if I say P is 1,000 and your rate is 8%, and you're compounding it monthly for 10 years. All right, so right off the bat, it's done monthly, not continuously. PERT is continuously. So you're not using PERT, you're using the other one. So yeah, you have to have a calculator, plug it all in.
Oh.
So I'm going to do it with you. So the first thing you do is just substitute everything. So $1,000 at a rate of 8%, and here's the key. 8% is what? 0.08. Monthly is what? 12. Once every month for a year is 12. So 12 times a year for 10 years. So you have to do your exponents first. That's 120. And then you have to do the parentheses. So you do work this kind of backwards. So 0.08 divided by 12 plus 1 is 1.007. I'm going to leave it as 0.00666666. On the calculator, add 1 to it, and then raise it to the 120th power. And it's 1,000 times 2.21964. And the 1,000 just moves your decimal 3 places to the right. So your $1,000 after 10 years, if it's compounded monthly, you just gained $1,200 that you didn't do anything for.
Yeah, I'm lazy.
But 8%'s pretty high rate, which is what you should get if things are invested wisely. But a lot of people don't invest wisely. All right, let's do continuously. So same problem, except continuously. So $1,000 times E, the rate is 0.08 for 10 years. What does that give you? Everybody figure it out. All right. So 1,000 times 2.22554. So move the decimal 3 places to the right. $2,225.54. So what's the difference? Continuously versus monthly, $6. Actually, $5.90. Not a big difference. But the bigger the deposit, the bigger the investment, the bigger the difference is going to be. So, all right. Graph it. Real quickly, everybody graph that as fast as you can. You got 5 seconds.
Well, I just somebody missed my one.
There it is. Anytime, first of all, you have to know what your exponential parent functions are. A to the x. Okay? So if a is between 0 and 1, meaning a fraction between 0 and 1, then we know that goes like this. Okay, you have these asymptotes here. All right? And if A is bigger than 1, which E is bigger than 1, it's 2.718. Okay? So this is going to go up if it's bigger than 1. Okay? Knowing the parent function, you should be able to graph any of these that I throw at you. So y equals e to the x plus 4. Graph it quickly. Okay, should be done. Again, the parent function, e to the x, goes up to the right. And what you should notice is this is inside the function. So that means you're moving horizontally opposite. Horizontal is always opposite, so to the left. All right, so you still have your asymptote at y equals 0. It didn't move up because we're only moving left. What's moving left? That point, the parent function intersection, 1, 2, 3, 4. Now you still have a y-intercept, except it's going to probably be a very, very, very large number. Well, not very, very, just large. If you plug 0 in for x, that'll give you your y-intercept. 0 plus 4 is 4. E to the 4th power is 54.6, so way, way up there before it crosses the y-axis. All right, let's do this again. Remember your parent functions. Do something different. All right, let's do y equals -3 to the negative x plus 9. There you go. So here's what I'm talking about. What I see is a is bigger than 1, so it's going to go up to the right. But it's got a vertical reflection. So instead of going up to the right, is now going to go down to the right. But then I see a horizontal reflection. So I take this and I flip it horizontally. So this is the shape of your curve.
So
This is a vertical shift. So your the asymptote goes up 9 units. Let me separate something here. Hold on a second.
so
Okay, so
if E becomes negative, it goes down.
because it's a vertical reflection,
Okay. And if the x is negative, it flips opposite, correct?
the parent function, yeah.
Parent function. Okay. That's
Remember,
fine.
outside your function.
I got confused. mixed
So
up.
here, real quickly, y equals a to the x. You have vertical movement in front of your function, vertical movement on the right of your function. Horizontal movement is inside the function, wherever x is. That's what all the equations are. So the negative's outside the function, and it's inside the function. So you both reflect it vertically and horizontally. And the 9 is outside, so that's a shifting up of 9 units. So your asymptote is moved up here, but you can't put the y-intercept 1 unit above. You also have a vertical stretch of 3, so now you actually have to plot a point. So plug 0 in for x and see how much that stretched it. So 0, negative 0 is 0, 3 to the 0 is 1, and you have a negative in front of it. So that's -3 plus 9 is 6, right? So 6 is right here. So it's a good thing you didn't put that point up there. This is what we're looking at. So it goes like this. Finish your quiz, come back, and say, okay, let's plot a point to make sure this is right. Plot a point on the left side or the right side of your y-intercept to make sure you have the line either going in the right direction. So let's put 1 in for x. -3 to the -1 plus 9. 1 was positive, but you got a negative in front of the x. What's that -1 do?
Makes -3 positive.
No, never. It changes it, flips it to the denominator. So the negative stays there. You have negative, and the 3 goes to the denominator, leaving a 1 on top. Plus 9. What is that? That's going to be positive 8 2/3. right? So at 1, we're at 8 2/3, which is right there. So this was a really skinny curve if you're going to draw it accurately. You don't need to correct it. You're just checking to make sure you have it in the right place. All right? Next. All right, do this problem. Smarty pants. 2 to the negative 100x equals 0.5 to the x minus 4.
And that one?
Okay, so listen to what I'm saying. I'm explaining how to do these problems, and if you just if you don't listen to the videos, it doesn't help you. If you're just copying down the problems, it doesn't help you. So how do you do this problem? The whole point of this is that you notice you have two bases set equal to each other with exponents. You don't have one base and an exponent, which is what you're going to have when we do logarithms. You have two bases, and the thing is, you can't do this problem if you don't have like bases. That's the whole point of these. You have to make the bases the same. You have to manipulate your numbers. Well, I can make 0.5 1/2, and I can make a 2 into 1/2. Isn't 2 to the negative 1 1/2? Right? But 2 to the negative 1 is not 2. So that doesn't work. I need to say 1/2 to the negative 1. Because isn't 1/2 to the negative 1 the same as the 2? Yes? Okay. So you have to make sure you're doing it the right direction. That's kind of difficult, but if you don't push yourself, you're never, ever going to get there. You've been learning since Algebra 1 and Pre-Algebra how to manipulate equation stuff. Now manipulate the way the numbers look. Now that the bases are the same, you can set your exponents equal to each other. You have to distribute the negative 1 or multiply negative 1 times that. So that's 100x. And that's just x minus 4. And now it's algebra. But you can't finish the problem unless you know how to start it, right? Duh. You can do this. Practice, practice, practice. I'm literally taking your quizzes and stuff from the odd problems. How about do this one for me? 9 x squared equals 3x plus 2. Go. So you got to get your bases the same. So 9 is the same as 3 squared. How many people got that far? Okay, good. Now, once your bases are the same, that's 2x squared equals 3x plus 2. Now you got a trinomial. Everything on one side. Factor. Set each one equal to 0 and solve. Yeah. All right. Inverses. We got a few minutes left. Tell me what the inverse of this is. Cubed root of x plus 1. Go. Okay, switch x and y. And solve for y. Subtract the 1. And cube both sides. Oh my gosh. Instead of writing all that out, we'll leave it like that for now. All right. What? All right, now how do you know if two functions are inverses of each other? So verify that these two are inverses of each other. Y equals x squared plus 5, and y equals negative square root of x minus 5.
Is this a separate problem?
No, these are together. How are they? Are they inverses of each other? There's two ways to do it. I explained it at the beginning of the video. One way is just find the inverses of both of them. So go ahead and do that. X equals y squared plus 5. Subtract the 5. Okay. And then you take the square root of both sides, and you have the square root of x minus 5 is equal to y. And again, that's a plus or minus, so yeah, you could say that is the inverse of the other one. But you have to check the other one as well. So switch your x and your y. Now, if we square both sides, that's x squared equals y minus 5. Add the 5, you get x squared plus 5 equals y. And yes, then you could say they are inverses of each other. The other way to do this is to plug this into the x. Usually you plug it in for y, right? But what happens when you do an inverse? X's and y's are switched. So that's why you plug it into the x of the other equation. So y equals negative square root of x squared plus 5 minus 5. We don't need the parentheses, right? There's nothing to distribute. So the plus 5 and minus 5 go away. And the square root of x squared is x.
Negative x.
All right? So you got plus or minus when you do that. So you've got to have it to be x. And that would be a check, yes. But then you also have to plug the other one into the first one. And it needs to be equal to x. So that's two different ways of solving it.